Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 977. Please turn to it. Page 977, and today is our lesson number 146. Today we'll begin the very last section of the very last exam. Page 977. This section contains 16 questions and they are all of the same type. They are all multiple choice questions, which means because they are all of the same type, it means that the scale of difficulty goes from 1 through 16. That in turn means that the first 5 or 6 are easy, the middle 5 or 6 are going to be medium, and the last few are going to be hard. Or if you want to keep your life simple, you can think in terms of pages. The first 2 pages that you see, page 977 and 978, those are easy questions. The next 2 pages that you see there, 979 and 980, those are medium questions. And the very last page that you see there, 981, contains hard questions. Let's begin. Number 1. On a scale of 1 through 16, number 1 is 1. It's very simple. Our restaurant menu, we are told, has 8 dinners. The menu has 8 dinners, and we are told that it has 3 desserts. And the question simply is, how many different dessert dinner combinations are possible? Well, it's very simple. It's 8 times 3. There are 24 different possible combinations, because for each dessert we have 8 different ways we can combine it with the main course. So 3 times 8 or 8 times 3, 24. Number 2. We are told that sum of 3x and 5 is equal to the product of x and 1/3. Which of the following equation gives the relationship stated in the problem above? So let's do it. The sum of 3x, their sum, which means we have to add them, sum of 3x and 5 is equal to the product of x and 1/3. We're looking for something that comes close to it. We may have to do some manipulations. We may have to get rid of 3 from the bottom. We'll look at the answer choices. See, nothing looks like that, so we're going to have to do some... Actually, no. That's it. We're done. There you go. It says 3x plus 5 equals 3x plus 5 equals 1/3 x, which is answer choice E. We didn't have to do anything at all. For a second I thought that we'll have to multiply both sides by 3 to get rid of this 3 from here, and then bring x to the ones. They're not doing any of that. The answer is this. 3x plus 5 equals 1/3 x. The answer is E. Next one. Page 140. Page 978. Next page. A clerk accidentally threw a valuable document into a clerk accidentally threw a valuable document into one of the 90 trash cans. Alright. So we have 90 cans, we are told, and the document is thrown in one of these cans. Obviously we do not know which can because it was done accidentally. One would hardly go and throw it in a can number 87 by accident. It is equally likely that the document is in any one of these 90 cans. Obviously, we just said it. If exactly 15 of these 90 cans are blue, so 15 of them are blue. 15 are blue. What is the probability that the document is in a blue trash can? Oh, they're making too much fuss about nothing at all. They're simply asking you what are the odds that the documents that you throw away is going to be in a blue can if there are 15 blue cans out of 90. Well, it's just 15 out of 90. The odds are 15 out of 90, or odds are 15 out of 90 that the document that you threw away is going to be in the blue can because there are 15 blue cans. 15 out of 90, divide top and bottom by 5. 15 divided by 5 is 3, and and 9 divided by 5 is, let's divide top and bottom by 3. Let's divide top and bottom by 3. 15 has 5 3's, and 90 divided by 3 is just 30, and we can go one more time. 5 divide top and bottom by 5 and get 1, and 30 divided by 5 is 6, so it's 1/6. That's it. The way I was going is that I was dividing top and bottom by 5 to start out with. There is nothing wrong with it, it just requires a little bit more thinking. So 15 divided by 5 is 3, and then how many 5's in a 9? 9 has 1 5. The remaining 4 goes and joins the 0, becomes 40. How many 5? Remaining 1 goes and joins 9 has 1 5. The remaining 4 goes and joins the 0, becomes 40. How many 5's in a 40? 40 has 8 5's. So now we end up with 3 over 18. We can divide top and bottom by 3. That becomes 1, and 18 has 6 3's. The odds are 1/6, same as before. The answer is 1/6. Let's go on to the odds are 1/6 that the document that you throw away is going to end up in a blue can. It's ended up in a blue can rather. Number 4. How many different integer pairs x, y satisfy this condition? So we have this integer pairs of integer x and y, and the conditions that they have to satisfy is that their ratio has to be 1 to 2. And the question simply is, how many different pairs are like that? Well, that's one right there. You could also have 2 over 4. That's 1 over 2 if you reduce it. We can also have, so in other words, this could be 2 and this could be 4, or we can have 3 over 6. 3 and 6, that will have a ratio of 1 to 2 when you reduce it. Or it could be 4 over 8, or it could be 5 over 10, or it can go on forever. So how many such pairs are there? The answer is infinite pairs are there. Is that all there is? Or did we leave out something? We left out 50% of the possible scenarios. See, dot 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 tells me that it can go on forever, but that's only half the story. Where's the other half of the story? It could also be this pair, -1 divided by -2. Do they tell us that they are positive? They don't tell us that. They just say how many different integers. These are integers, that's all. They don't tell us that these are positive. These are just integers. So it could be -1 divided by -2 is also 1 over 2. Or it could be -2 divided by -4. It could be -3 divided by -6. It could be -4 divided by -8. -5 divided by -10. So that's the other half of the story. But anyway, the point here is that there are infinite such pairs where the ratio is going to be half. The answer is E. Number 5. In number 5 they gave us a graph here. According to the graph above, during which of the following 2 months period this Allen bookstore sell the least number of books? Let's do it here. I'm not going to put the graph. I'm going to leave it up to you to look at the graph and follow me there. June and July. June and July. June and July. It comes out to be 8 plus 40. If you look at the chart properly, you don't have to be, it could be 7. Somebody could say that this is 7, it doesn't really matter. It's 8 or 7 or 8. And then July is exactly 40. So it's about 47. B is July and August. July, as we say, is 40. And the August is about 10. And since the question is saying during which of the following 2 months period did Allen's bookstore sell the least number of books? We're looking for the least number of books. Keep that in mind. We're not looking for the most number of books, we're looking for the least number of books. Since this is 50 and this is 47, 50 is already more than 47, so we know B is not the answer because 47 is less than 50. Let's look at C. C says August and September. August we know is 10, and September, if you look at the graph carefully, it comes out to be about 33, 34. So is about 43. Well, that one was 47. Since we're looking for the least number of books, that one is out of the game. So far the answer is C. So far C is the least one. Let's look at D. D says September and October. September we said was 33. In October, it's about 25, I would say. Whatever it is way more. It's already more than 50. It's more than 50. This is only 43. D is not the answer. Let's look at E. October plus November. October we said it was 25. And November, oh, November is way up to 30. That's more than 50. This is only 43. That's not it. The answer is C. The least number of book sales she had in the 2 consecutive months were the months of August and September. And that's it. Pretty straightforward, pretty simple. Number 6, okay? Next one, last one. Problem number 6. In the picture above, AC equals 24. Alright. So here is our A to C, and we are told that A to C is 24. So far so good. A to B equals B to C, we are told. A to B equals B to C. So let's put down here A to B equals B to C, which means A to B is 12 and B to C is also 12 because it has to add up to 24. Let's keep reading. Point D, which is not shown, is on the line between A and B. So D is somewhere between A and D such that, so it's not just any old point between A and B. There is some conditions we have to meet such that A to D has to equal D to B. In other words, D falls right in the middle here. A to D, this distance here, has to equal this distance here. Since A to B is 12, this is 6 and this is 6. And this is 12 from B to C. What is the question asking? The question simply is, how long is D to C? D to C is simply 6 plus 12. 6 plus 12 is D to C, which is equal to D to B plus B to C. The answer is 18. The answer is 18. The answer is D as in David. I will see you tomorrow, where we'll continue our journey. Alright? We're getting very close to the end of the book, the end of the exam number 10. Okay? Few more days to go, 2 or 3 more days to go, and we'll be done. I'll see you tomorrow, okay? Bye now.